Now we come to the really big boy stuff.
Yes.
No one in the world has done this tag before. Omni-ID is a market first, but we are really doing a great, this is our highest growth product in the company right now. We have 7 of the top 10 automotive manufacturers installing this tag already, running a number of pilots and trials in their manufacturing facilities. So this is what we call visual tagging. What's visual tagging? Well, there's a big problem in RFID generally, in that while RFID is trackable and the system can see where the assets are, the human who's looking at the RFID tag can't see anything. They don't know that the system has read it or not read it. And you've heard about the 99% problem.
Yep.
If you miss 1%, how do you know you missed it? You can't tell. With a visual tag, you have operator readable instructions. That solves the 99% problem. So for instance, if this container came in the back and the tag said, deliver me to dock door number 3, when it comes through dock door number 3, if it gets read by the system can say, yes, I read you, and the instruction could change to say, take me line side to flow rack 42. In that way, I know that every single thing, 100% of every container that got line side was read by the system. If it didn't get read by the system, the screen doesn't change, and I know that I have to put it over into QA area to be received separately.
So the tag is basically speaking or telling the operator what to do with it.
Exactly. We call this a smart container. When you have a tag, it's an Internet of Things type concept where the container can tell the worker what to do with it. I'm supposed to go line side. I need to get on the 4 o'clock truck. Paint me blue. Take me over for inspection. This little smart device is recording the whole life of this container, and it might be loaded with a recipe that is what it's supposed to do. A good example today. Today when Toyota orders left-hand mirrors for their Corolla, they will fire off a demand trigger down to some supplier that makes the left-hand mirrors. And they will typically print out little white Kanban cards on paper, and that supplier will produce left-hand mirrors and fill them in containers. Now, instead of doing that, the container's already sitting here with a smart tag on it.
Okay.
And that order will come directly from the cloud and can be loaded directly to that tag saying, fill me up with left-hand mirrors.
Okay.
And every step of the process, painting the mirror blue if it has to be blue, putting the chrome attachment onto it, whatever customization can be on here, as well as the delivery information. I need to go to Toyota, Kentucky. I need to be delivered by Tuesday. I need to, when I get inside the plant, I have to go to the flow rack. I have to be line side. They all can be encoded and tracked. So what does this give me? First, it eliminates paper. Right. No more paper printers or labeling. And no humans that have to pick up the paper and walk it and get it onto the right bin. That's a huge savings already.
Without a doubt.
But then I get all the traceability. This thing is recording its history. If I'm a logistics manager at Toyota, I can think, how long did my inventory lie there? How long was it before it got picked up? Did it get put on the right truck? Yep. I can do quality inspections and quality holds. If I've got a supplier on probation and I want to pull randomly 5 boxes for inspection, I can do that right from my computer screen, and right away a Ghostbuster stripe will come through here saying, take me for inspection.
Okay.
You can't do that with paper, right?
No,
right on receipt.
Not easy.
And you capture all the analytics data of all who worked on me, if I have recalls and things. So there's a lot of benefits to this kind of a thing. There's a button that allows an operator to press.
Okay.
That allows me either to say forward a page, but it might also be that I'm out of parts. I need this thing to be replenished.
So you could send a signal from the tag to a central location to say, replenish me.
Exactly.
Okay.
It could be replenish me, it could be that I'm short, it could be I'm doing a partial. Whatever you want to program the tag to mean, it's soft keyed so it can have whatever meaning you want for your application.
Okay. And what's the technology? Is this RFID, passive, active? What technology is
all of the
working?
above.
Okay, so maybe you could explain a little of that.
There's a convergence of some key technologies.
Okay.
The first is the e-paper that's on here.
Right.
It's essential to have e-paper because it doesn't draw any power when the image is not changing. That allows us to get 5 years of battery life on this. Without that technology, you couldn't do this concept because you'd be constantly changing batteries.
And that's the same technology we have on our Kindles and reading devices, that's e-paper.
It's now matured, it's come down a lot in price. All the patents have run out last year from e-ink. That allows this now to become much, much more accessible for this marketplace, and the prices keep coming down all the time. So we believe this will be pervasive across our industry manufacturing because it's really becoming so cheap to make that you'd be silly not to do it. The typical ROI we're getting just on paper replacement, forget about all the advantages we talked about, most of our customers are saying 9 months worth of printing pays for this tagging system.
I believe that.
And if it lasts for 5 years, you've got 4 years plus of free use just on paper without the extra command and control benefits, without the analytics benefits, without the quality benefits.
No more need to print barcode labels and tag things. It's
all that stuff.
You just send the information and there it is.
Exactly.
Okay.
The other technology, so e-paper is one piece. The second piece is the active radio. Active radios have come a long way. They draw much less power than they did before, and they're much cheaper than they were before.
Okay.
So putting an active radio in here is simple, and the 433 is a wide open band. It's not, you don't need a license, you can use it anywhere, so that's really, really helpful. The third part, as we mentioned, is the passive and active linkage. It's only recently that companies like NXP and Impinj have brought out RFID chips that have serial bus connections.
Right.
And they're doing it specifically for the IT marketplace where laptops and tablets need that kind of linkage. We're using and leveraging that technology here so that the passive and active can be linked. And that's a key piece of it. And the third, frankly, is battery technology. Battery technology has gotten much better, much cheaper, much more persistent, where I can get a 5-year battery that's cost effective. So this couldn't have been done 5 to 10 years ago effectively. Omni-ID is leading in this, but we don't believe we'll be the only one. We know that we're paving a pathway here that a lot of people are going to look at, and I'm sure we'll have competitors soon. Yeah. But converging these technologies together into one product is what we've done, and we think we've done it pretty well.
Yeah, it's very innovative.
Yeah. So we make them in a 3-inch size, a 4-inch size, and now the big new 10-inch size.
So that can act as a tag as well.
We call it a tag. Everybody looks at it and thinks it's a tablet.
Right.
It's a tag. It's not a tablet.
Wow.
But it's a paper replacement in that these will replace label-type paper. This will replace a full build sheet. We have this deployed in a number of our automotive customers today. In fact, Daimler is here today as our booth guest. They just went out to lunch. They've installed it in their plant in Detroit, and they're replacing a build book that was building engines previously with this electronic tag.
So the instructions are sent, the bill of material refreshed. Wow.
So you might ask, what's that advantage? Well, it means that this thing can travel with a complex engine down a line. As it travels down the line, we have small emitters. These happen to be infrared emitters. We can trigger with infrared, or we can trigger with passive RFID. The infrared emitter emits a code that's received here in the sensor, and that means that this can flip to the right instruction for that build cell. So if I'm the paint cell, and this engine is coming down the line, I've associated this tag with the engine. When it gets to my station, it automatically picks up that code, it flips to the paint page, and it says, paint this engine blue. Silly example, but...
Yeah.
But not only does it do that, remember at the same time I'm tracking it, and that means that I can confirm the engine got to the paint station. I know that Mark worked on it at 4 o'clock, and that he painted it blue. Or if it didn't get painted blue, it's his fault because it's said to paint it blue, and I know it went to your workstation. Right?
Gotcha.
The other problem they had was that they have a lot of quality inspectors inspecting engines. And if they gauge it and it's out of tolerance, they have it reworked. They used to go with big crayons and mark up the build sheet to send it back to rework. It was impossible to capture that. And so they lost that information. If it went to rework and there was an issue later, they had no idea that engine had been reworked. Now the write-up happens right here. So if it goes here and it goes for a pass, they press button 3. Okay. If it doesn't pass, they press button 2.
And it's back in rework. Yep.
The quality inspectors have handheld units where they have their own little interface where they can say, I want it re-gauged to whatever, and they hit this tag, that updates the instructions, so now you have it, and not only does it update the instructions, it digitally signs which inspector asked it for rework, what station it went back to, and of course we're capturing the time. How long did it take him to do the rework? We know when it arrived at the station, we know when it left at the station, and we can give all that rich analytic data to a supervisor to start to plan their production better. Wow. So this is more than just replacing the paper. It's a whole new process paradigm. What I often say when I talk to our manufacturing customers, imagine that your assets could tell the workers what to do to them, and that you can track exactly how they're interacting with that asset. Track the time, track how fast, do instant quality holds, do instant inspections. What would that do for your process?
Yeah, really.
And outside of the paper replacement, there's a lot of money and value there.
Certainly.
Now, we talk a lot about manufacturing because that's Omni-ID's main focus with this product line. But you can think about the applications in healthcare, for instance. Put one of these emitters in a patient's room, and when I walk in, immediately the records associated with that patient are displayed automatically with no manual intervention.
Right.
I might have this hanging on the bedside of Mrs. Smith, and I take Mrs. Smith down to the operating room. If this emitter is the operating room emitter, it picks it up and says, oh, is Mrs. Smith supposed to be in this operating room? Yes, it is. You need to operate on her left leg, not her right leg.
Send all the instructions right over
all
just
those
by recognizing
are right on there.
Who was in the room.
And not only that, now I know who was there because all the staff are tagged. I can say who did the operation, how long did it take. I can get all that records captured automatically with no paper and trap that. As an example, the same kind of examples are there for transportation in airports, for entertainment at theme parks, for all sorts of things that visual tagging, anywhere where you have a cyclic process where things are repeated, this is a great technology to eliminate the paper and create an interaction between people and system.
Awesome.
All right?
Yeah.